Welcome back, YouTube. This is Dave Lucas with Injection Molding Skills and More. So today's video, we are going to go over a velocity curve, how to set the velocity curve and how to load these steps. So let me go over this. I didn't have enough room to write this on my board, so I'm going to read this to you, okay? So the purpose of this test is to determine the optimal injection velocity for a particular material, mold, and part design, okay? This spreadsheet that I'm going to give you guys, I'll have it over here in the corner somewhere, will show you this, okay? Can be used to provide a graphical representation of molecule alignment, okay? Orientation. The faster a plastic material is injected, the more aligned, oriented the molecules become, okay? So this is what this test is going to go over, and hopefully you guys can see over here. I'll put over here in the corner the whole graph and everything when I'm done, okay guys? So let's jump into this. So the first thing you want to do is you want to load your tool, okay? Get it in there, get everything set up correctly for your mold. Then you're going to begin to attempt to process a full part. So you're going to do everything you do to get a full part, okay? Once the part is filled out, it is time to begin collecting data, okay? So what you're going to do is you're going to collect the data from the fill time and pressure at transfer will be the inputs obtained from this machine display, okay? So the way this will work is you'll have your graphs all set up over here, and that's what you'll go by. Number 5, the machine set velocity will be the only setting that the operator will adjust. 6, begin adjusting the injection velocity in normal increments, or how you say that word? Try to say that word a bunch of times. Nominal increments. Okay? And then number 7, you're going to record the fill time and the pressure at transfer, every adjustment that you make. Repeat this procedure 15 times to develop a process to develop the curve, okay? I do have them over here. I will show you guys. Once a curve has been created, pick a location at which the curve begins to break. Adjust the point to a few settings faster to accommodate changes in material viscosity. 11. Mark this location with an X on the chart, okay, to the left in the column titled point break, okay? So you're looking at that chart, you're looking all the way over to the far column, so you're gonna have your fill, your pressure, and that over there. This value should be used as an optimal injection velocity, okay? So that's what you're looking at. So over here, I will put the graph up for you guys and let you see this. So what they're saying on here is that once you have determined all this on your scale here, what your results should do is the viscosity curve states almost vertical, okay, and the beginning to transition to a horizontal line, okay? So if you're looking down here and you're looking at that chart over here I'm showing you guys, you'll see that. The curve represents a maximum a line of molecules in the polymer can endure. Okay, endure. Oh, I'm crazy. The point at which the curve begins to transition is referred to the break point, and is the optimal value for viscosity and pressure. The point break is the slowest recommended injection velocity. The injection velocity should be slightly adjusted to accommodate variations in material viscosity. So if you see that over there, you can see the platform I have set up already. Note, the relative velocity data graph helps users indicate where the relative velocities has stabilized. A flat line shows where the relative viscosity is stable. Therefore, selecting a breakpoint should be selected within a table range. Okay, so make sure you guys have that set up correctly right there. You know, that chart should be set up perfectly. So you want your chart to be, you know, 1 through 15. You want the machine set velocity, and then you want your fill time in one column, pressure in the other column, and then your point break would be on that, whatever you're setting your point break at. So at the top, you're going to have your intensification ratio, your screw return position, including decompression, whatever that distance is, okay? And then you're going to have screw position at transfer from fill. That'll be that column there. And then you're going to have the total stroke in inches, okay? This is how you do a velocity curve. If you're having problems with your press or anything, or you're not getting the injection speed that you're actually asking for, this can help you on your machines, okay? So think about that whenever you're processing. This can help you out, okay? So, like I said, I got the graph sitting up over here. Look at it. Make sure you guys are familiar with this. I do have an Excel file to where I could send this to you if you really wanted this. Please comment, share, like. I really do appreciate it. Comment down here in the comment section. Until the next video, peace.